Hello and good afternoon, everyone. Welcome to this latest session in GreenWeek, where we're going to talk about innovation in energy-intensive industries. My name is Sonja van Rensen. I'm your moderator for the next hour. I'm the managing editor of Energy Monitor, which is a new website launched by the New Statesman Group last autumn, dedicated to the energy transition. So the idea is that we're going to talk about technologies. Breakthrough technologies, innovation, can often do more than one thing. In practice, they can help deliver or get us closer to climate neutrality, and they can also help deliver traditional pollutant emission reductions. We're here to talk a little bit and to reflect on the potential synergies there, and in particular, the potential role of one instrument, the IED, or the Industrial Emissions Directive, to promote such innovations. The IED, which I'm guessing most of you are probably familiar with, is the EU's main instrument for regulating pollutant emissions from industrial installations, and that's more than 50,000 installations in total. It is not something that has traditionally regulated greenhouse gases or CO2, but that's one of the ideas on the agenda for a review of this directive, which is on the agenda for this year. So that's for a very short intro. I'm conscious we only have an hour. We have a full program. Nonetheless, it's not just us who are going to be doing the speaking. We're also here for all of you watching and joining us today virtually to take your questions and ideas and inputs. So to do that, we ask you to log on to Slido, slido.com. The code you need to enter, there it is EU GreenWeek 2021. And we're in room 3, or you should see the title of our session there. That's Innovation in Energy Intensive Industries. And what we wanted to do before kicking off with our first speaker was to put a question to you, a polling question via Slido, to get a little bit of an idea of where you think the greatest potential is for innovations to reduce emissions in industry. So can we have the first Slido question, please? The first polling question. And that question is, which of the following decarbonization options offer the highest level of greenhouse gas emission reduction, do you think? And you can pick 2 of these. And we'll give you just a moment to do that and see what comes up as those options you think have the greatest potential. Renewable energy is up there, process innovations as well, I see. We'll give you just another second or 2. And I can already tell you now, our first presentation is going to provide an answer to this question. So I'm not going to tell you what the right answer is. I'm going to leave that to our first speaker. I'll leave you just another moment. Perhaps I can reintroduce our first speaker while you're still voting. So I'd like to welcome Keir McAndrew. He's here from the consultancy Wood. He started out at the Scottish Environmental Protection Agency, working on industrial pollution control. Subsequently joined the European Commission back in 2007, working on the IED, no surprises there. Has worked across other environmental issues such as transboundary air pollution and heavy metals, including also notably mercury regulation, before joining Wood back 6 years ago now. And one of his areas of expertise is clearly industrial decarbonization. So looking at the results on Slido, renewable energy sources is coming out as number 1, process innovations as 2nd, and low carbon fuels as 3rd. Well, I'm going to leave it to you, Keir, to reveal to us in a moment where the greatest potential actually lies. So go ahead.
Thank you very much. I feel like I've been placed in a slightly unenviable position here. There is no single answer, to be honest. But what I'll do is I will give an overview of the study that we performed on behalf of the European Commission to look at this very topic. So really looking at innovation in energy-intensive industries and focusing on the relationship between decarbonisation objectives and wider environmental protection initiatives. The study was undertaken by Wood in partnership with Deloitte and the IEP. The project was initiated at the very end of 2019. Much of the work was completed over 2020. And the final publication of the report came in March of this year, and you'll be able to find it using the links from the Commission's website. And the idea was to provide a clear picture of the potential wider environmental impacts of the transition of industry under the scope of the Industrial Emissions Directive to a low carbon circular economy. And the context behind this, and I think you gave a very good introduction to it, was that despite the good progress in reducing greenhouse gas emissions, substantial reductions are still needed for the EU to become climate neutral by 2050. And the way that the IED contributes to that particular target was a part of what we looked at. So, given that I've tried to summarize what is a rather lengthy report and a very difficult subject into 5 slides, what was it that we found as part of the assessment? So first of all, we looked at what types of technologies there are out there and their technology readiness level. So what we identified, given the broad range of activities that fall within the scope of the Industrial Emissions Directive, is that there is a high variety in the type of technologies and their potential impact on greenhouse gas emission reductions. When it comes to innovative decarbonization technologies, so looking at process emissions versus options addressing greenhouse gas emissions from combustion of fossil fuels, obviously the kind of technologies vary and their impacts vary accordingly. The majority of the technologies that we identified as part of our study are related to the reduction of CO2 emissions versus non-CO2 greenhouse gas emissions. So they really focus much more on a particular greenhouse gas rather than addressing, for example, methane emissions, which is somewhat understandable given the focus of the EU emissions trading scheme, which doesn't address all greenhouse gases. And the implementation of some of the pathways for decarbonisation are somewhat out of the control of the operators concerned. So evolutions in segments of products, value chains, other than those under the scope of the IED, could potentially drive or necessitate changes in production processes with an impact on associated greenhouse gas emissions of production. So if we look at the Slido poll and the fact that renewable energies was up there as one of the key decarbonisation technologies, obviously, when it comes to IED installations, not all of them can install their own wind farm or their own solar panels to power their particular facilities. So decarbonisation, to a certain extent, is reliant on their suppliers to the processes that they are operating. What we then did is looked at different technologies and where they sit in terms of their readiness. So if you look at this particular chart, we have the greenhouse gas emission reduction potential on the axes running vertically and the technology readiness level. So how close to operation are the particular techniques themselves across the bottom axes. And what we did was look at a variety of different sectors, the types of impacts that could be addressed by these particular technologies and their readiness. And as you can see, there are a broad range of technologies out there which can be applied, and they have various levels of readiness. So some of them are still very much in the kind of pilot phase or in the early development phase. Others are much more familiar and sit more towards the higher levels of technology readiness. And obviously, the more I click, the more technologies you see as part of this particular graphic. With the expectation, as you move towards the higher levels of technology readiness, you would expect to see a great number of technologies in this particular chart. Now, understanding that there are a number of techniques applied to address decarbonisation, we were then looking at, well, what does that mean in terms of potential other impacts on the environment? So if I am looking to install a particular technology, does it have negative or positive impacts with regards to wider environmental issues? So here, based on information we collected from literature and during interviews with representatives of the different sectors concerned, as well as hosting webinars with experts, we performed this initial assessment. So it doesn't go into the details of the total quantitative impacts of all of these particular technologies, but it looks at, if you employ these techniques, will they lead to more or less pollution of the water, more or less pollution of air, higher or lower levels of waste generation? And what we found in general is, looking across these environmental sphere, that normally we were looking at win-win situations. So when you're looking to address decarbonisation, there are technologies which also allow the reduction in air pollution or water pollution. But of course, this isn't a universal thing. In some cases, there are additional costs which stem with regards to discharges into other environmental media, as well as looking at air and water, which are shown on this particular slide. Of course, we looked at energy, resource and waste, soil and ecosystem impacts, and also indirect impacts as part of this study. So I'd encourage you all to go and look at the results of this particular piece of work, because it forms an important aspect of understanding how the IED sits with regards to decarbonisation and the integrated approach, which is a fundamental aspect of the directive. I think that's the end of my slides, and as much as I can fit into 5 minutes. So thank you very much for your time.
Perfect. Thank you very much for that. I appreciate 5 minutes isn't much to wrap up condense an entire report. And thank you too. I appreciate the question is not easy to answer. Nonetheless, I noticed on one of your charts, some of the options we had up there, notably renewables, was up there with a lot of emission reduction potential. I also saw two that we actually, or our audience today, had put quite low down on the list. One was carbon capture and the other one was materials recovery and recycling. I think nobody had ticked that one, but that's actually up there on your chart at least. It's something with potentially a lot of opportunity. So we learn something every day. Thank you, Keir. What we wanted to do now then was move to two presentations that give us some insight into innovations that are actually being developed on the ground. These are two LIFE projects. So LIFE is the EU's main funding tool for environmental and climate action. And we have representatives here from, as I say, two different projects, and they've actually, implemented innovations, developed these on the ground, and are now looking to then incorporate these potentially into best available technology reference documents, which are ultimately taken up into the operating permits of industrial installations under the IED. Right, that's quite a mouthful. So without further ado, first up, Marco van Valburg, Strategic Program Director for the LIFE OptiMelt project. Marco is originally a mechanical engineer, has worked in the glass tableware industry for a very long time. I saw more than 30 years. He's Secretary General of the Dutch Glass Association and also Vice President for Engineering at Libby, which is one of the world's largest glass tableware manufacturers. So Marco, over to you to give us a flavor of what's actually already happening these days.
Okay, thank you. Let's experience whether the clicking works. Welcome to this presentation. I will quickly try to move on to the next slide. This is not working. Why is this not working?
Can we have the next slide? Someone's going to help you if it doesn't work. Yeah.
Okay, before we step into a few minutes of technology and innovation, I want to share with you who we are. We are Libby. We are a US-based company with several plants over the world, and basically we are a glass tableware manufacturer. I put in here some pictures. We produce basically everything from glass, which is on your or my table. We also produce some packaging type of stuff. More these days is water bottles, of course, in all kinds of colors and shapes. But basically we are a tableware company that produces glass in every color, every box for online, mainly for retailers, food service, B2B. Okay, let's move on to the next slide. The project we have been running, and actually we performed the project in 2017, so we have now 4 years of operational experience, and I'm very happy with the project. Our challenge was to reduce our energy by natural gas, which is the main energy source for current glass melting. We managed to reduce this, we wanted to reduce this with around 50% in our glass melting process. Accordingly, the CO2 emissions reduction, and besides by improved combustion system, we wanted to improve our NOx emissions by around 30%. If we click, then you can see already the results step by step. The energy reduced with 48%. This is a two-step process. I will explain in the next slide. We have reduced more on CO2. This has to do with the difference in the energies because we have also spend some energy on generating oxygen on site now. Our NOx even reduced more, 80% plus. and we reduced on our SOx sulfurs by close to 60% by this project. So this is clearly a result with energy and emission reduction, greenhouse gas reduction. In the next slide, there is a visual where you can see what we have done. Basically what we have done, we have took two of our previous glass melting furnaces, L7 and L9, we have combined them into one bigger furnace. And one bigger melting furnace already gives you an improvement in energy efficiency. The second step we did is we transferred the combustion system. Normally, historically, we work with gas and preheated ambient air. And the preheat is coming from the furnace. And we have transferred the air to pure oxygen. So we are now running with gas and pure oxygen. This is already known technology, nothing new. But it gave us a second step in energy improvement and in reduction in greenhouse gas. And then the third step came to the right, to the green one, where we installed an innovative heat recovery system. It's typed as OptiMelt. It's on the market now. We are the first factory that implemented this and demoed this, and it's 100% operational, running very reliable. With OptiMelt, we have been able to reduce additional on energy and CO2. In the next slide, I will try to explain you, it requires some clicking, which I will address. In steps, I want to show you a little bit of the technology to get understanding. What you see in the middle in the blue box is basically representing the glass melting furnace, showing the glass going from batch to melted glass. You see some lines which are the feeders going to blue circles, and if you look well, you can see a small glass over there in black. It's a cocktail glass. So we produce all kinds of glasses. If we click, we will see next steps. We have built a heat exchanger, which is made of brick, hot resistance refractory materials. And if we click again, we will see that we put batch, which is sand, limestone, all kinds of materials, and also pre-consumer cullet that goes into the furnace. Because the furnace not only produces glass, it also produces quite some heat. Flue gas. This flue gas, if we click, it goes by the red arrow. We preheat this heat exchanger. So far, nothing new, basically. We just heat up that heat exchanger. But what we do by clicking is we add natural gas. We just inject natural gas from ambient air, ambient temperature. We inject it in that hot heat exchanger. This, together with some of the flue gas, which contains carbons, that will give us a new type of gas. We call that syngas. And this is hydrogen, CO, and some carbons. And this very hot syngas, together with clicking oxygen, will give us a new combustion system. So where we come from gas and air, we went to gas and oxygen, and now we go to preheated, change to syngas, gas plus oxygen. And that is the new combustion. That gives us this additional energy saving. Of course, there is still flue gas remaining. And if we click a few times, we can see this still goes through a dust filter, flue gas filter, to capture particulates. And also we do some SOx abatement, and it goes out of the chimney.
I have to ask you to wrap up in a moment, I'm afraid.
Yeah, and the last click is showing the same results. So already shown. So we can move on to the next slide. So we have applied this technology and discussed this also with the BREF committee. So this all went to the Joint Research Center with our results, of course. And of course, it's a challenge for business to find the right business economics, cost benefits, together with environmental things, the steps up we want to make. We got feedback that this technology will be reviewed, whether it can become a part of the new BREF for glass. It's all the way up to the hill, up to going from good to better to best, of course. In the last slide, last box over here. It's important, this kind of project, that you believe in yourself. You take risks, a balanced risk. What is balanced? If nobody sticks out his head, nobody will gain. So we have to be open and share results and work together. Join things like these events. Yeah, and we have to accept as businesses also a realistic, undescribed realistic push, whether it's BREF or local legislation. Yeah. We have to work together to get it done.
Great.
Thank you.
Thank you. Thank you very much, Marco, for a great example of what's already possible. We have a second example, and this is the Green Foundry project, a second life project, and representing or presenting that is Sarah Tapola. She's the project manager for it, has worked as a project manager for a variety of life projects over the last 10 years, with a focus in terms of subject matter on energy savings, emission reductions, and waste management across different industries. So, Sarah, over to you.
Thank you. Okay, as a background, in foundries, the major environmental problems, they are related to emissions when the melted metal is poured into sand molds. Sand molds are made with organic binders such as phenol and furan-based resins, causing harmful and hazardous gases like creosotes, carbon monoxide, polycyclic aromatic hydrocarbons, and BREFs compounds, which can also be carcinogenic and mutagenic. Now, by exchanging to inorganic binders, which are silica-based and water-soluble, the waste foundry sand will be cleaner, emissions are minimized, and indoor air quality will be better. Next slide. Shortly about our consortium, we have 11 partners from 7 countries. We have foundries where we demonstrate this use of these inorganic binders. Then we also have universities, SMEs, and foundry associations. Next slide. The main objective of the project is to demonstrate these environmentally friendly inorganic binders in iron and steel foundries. The aim is to decrease hazardous airborne emissions and improve the indoor air quality in foundries. Also, the aim is to reduce the harmful substances in foundry waste sand and to increase the use of the foundry sand in new applications such as composting material, green construction and road construction purposes, or even in noise embankments. But most importantly, it is to reduce the amount of foundry waste sand to be landfilled. Next slide. What we do, we measure the emissions and indoor air qualities in 5 pilot foundries in Europe, and they represent both organic and inorganic binder systems. Then we also measure the total emissions in small-scale tests with different inorganic and organic binder systems, and then we compare the results. In pilot foundries, we produce the production scale test casts using inorganic binder system molds and cores, and those pilot foundries we have in Finland, Estonia, and Italy. And finally, we demonstrate different innovative cleaning and reuse treatment methods for the foundry waste sand. Next slide. About these emerging technologies, we demonstrate 2 kinds of different emerging technologies for air quality improvements and then technologies to improve the foundry waste sand quality. Inorganic binder system technology is tested now in new applications as in iron and steel foundries. So far, these binders have been used in production scale in few aluminium foundries in Europe. The aim is that ferrous foundries would introduce these new inorganic binders in mold and core making in near future. And so far, our test results and experiences in our pilot foundries have been promising. Secondly, we also demonstrate these innovative foundry waste and cleaning and reuse technologies. And these are composting method, where the foundry sand is cleaned by composting process, and then it can be reused in composting material for green construction purposes. Then we also demonstrate thermal reclamation and washing methods to recycle the cleaned sand back to foundry processes. And finally, we also test new innovative microwave ultrasonic method to reuse the cleaned sand in core making processes. And so far, the test results show that this composting method and thermal reclamation results have shown good results, and they are feasible and replicable for wider industrial use in future. And the final slide. Shortly about the results, By introducing this inorganic binder system in foundry processes, it is possible to reduce the airborne emissions from casting process by 90 to 95%. Such emissions as carbon monoxide, volatile organic compounds, polycyclic aromatic hydrocarbons, and BETEX compounds. It is also possible to improve the air quality in foundries by 70% and then also diminish the health risks of the workers. And then it is also possible to reduce the waste problem, which is related to the hazardous surplus or waste foundry sand. To increase the recycling of cleaned foundry sand back to foundry processes, it is possible to reduce the need of virgin sand and then reduce the total amount of waste sand to be landfilled. And by using these inorganic binders, the foundry waste sand will contain less harmful substances, and it can be reused as such already for new applications, such as road construction, green construction, noise embankments, or as a raw material for composting processes. And our final and main goal is to provide all these results and experiences for the preparation work for the ongoing reference document on the best available techniques in the smitheries and foundry industry. Thank you.
Okay, thank you very much for a second very interesting example showing how much you can do with one innovation in terms of reducing a whole mixed bag of different kinds of pollutant emissions. Thank you very much for that. What we wanted to do was in the second half of the session is get stuck into a debate on innovation and how the IAD could be revised to better promote it. A reminder that you can send in questions via Slido. I've already seen a couple come in, so we'll try and integrate those into our discussion as far as possible. Then to kick off our panel, I wanted to invite Chris Allen to take the floor. He's the Deputy Head of Unit at DG Environment, working on industrial emissions and safety. Is originally a chemical engineer, worked in the private sector before joining the European Commission already a number of years ago now. So Chris, maybe to give us just a very brief introduction as to why is the IAD being revised now to specifically to take into account innovation more than it has done in the past? And what are one or two ideas on how it could do that from your side?
Thanks, Sonia. And indeed, I think colleagues who have spoken already have made the case of how technical things are and how we need to have policy that actually can meet those this link to technical issues. So to answer to your question in simple terms, just in a nutshell, we all know that we are entering a phase of intense industrial transformation, and the Industrial Emissions Directive, if it's to play a role in the future, it has to be fit for the future. It has to be fit for accompanying this transformation. And so that's why the focus on linking the IAD to innovation is really central to what we are doing now in reviewing the IAD. To complement that, we can go back to the evaluation of the IAD that was published last year. And it basically says when we are looking at innovation, to what extent does the IAD work? And what we see is first, the IAD is just backwards looking. We look at what is best available techniques. They are there, the best techniques. And so you level the playing field. Those who are not using best available techniques, they get to that level of performance. But it's backwards looking, so it doesn't promote new techniques. It seems to have a pull effect in the sense that if you say, oh, there'll be a market for new BAT, so developers, if you come with new BAT and you put it in a BREF, you'll get a market. So that's sort of one impact, but it's not direct, looking at innovative technologies. What we see, and it was really illustrated by everything we heard already since the beginning of this session, is that if we look at the future, if we look at this transformation, we can't look at pollution alone. Up to now, the Industrial Emissions Directive was looking basically at emissions to air, to water, pollution of soil, these type of issues. Well, now it will have to, in the future, be an instrument that enables synergies between typically climate and environmental pollution issues. And how to do that is really very much the focus of what we are looking at. We have gone through public consultations and expert consultations over the last 6 months. And we see from there very much that if there's one topic in the review of the ID where all stakeholders say to the Commission, go ahead, it is linking the ID to innovation. Now that's easy to say, it's not easy to do. And you ask for a few ideas. Well, you know, our ideas are basically out there in our consultation documents. But what I wanted to just sketch out is what maybe it could look like in the future. The first thing is that we need a place to look at progress of innovation. Keir presented these graphs, and if these graphs could be updated regularly with all the detail that's behind, it's not just a graph, it's an enormous report. But if that would be updated and complemented regularly, it would enable industry, stakeholders, NGOs, member states, but also different policy, I would say, makers from the Commission to come together and to use that knowledge as an instrument for policy coherence. And so what's the temperature in the different sectors? What can we do to further promote the progress in innovation? And so that is what we call an industrial emissions innovation observatory. It already exists as a small scale, very technical, but we would want it to look basically at the industrial transformation dynamics. And then what would it do? Well, it would be the place to link the policies. It would be a place where we really get people who know about innovation, so that in our BREF documents, in our BAT conclusions, we could reflect that. We could reflect it also by saying, well, you know, these technologies, they are nearly there. Actually, they will allow us to this level of performance in the future. And we could reflect that, this information and those benchmarks in our documents. And then it could say, well, actually, these three sectors, they still need time to get to have the technologies. Those two, they're really now sort of nearly there. So if you're going to revise a BREF or a BAT conclusion, do it on those two, not on the three that just need time, because you have an opportunity to help those front runners to invest and to accelerate this innovation. Yeah. And this would be, what this observatory would do, and it would then be linked to some mechanisms we would put in the permitting system. You're probably all aware that when we publish something on BAT, we call them BAT conclusions. There's 4 years for industry to comply with the performance levels. One of the ideas is to say, well, actually, if we can put in our BAT conclusions, performance of BAT is 10, and performance of these innovative technologies that are already very close to being ready is 10 times better. Well, if you go for the 10 times better, you don't have to go for the BAT, and you'll have more time. You won't have 4 years, you'll have 6 years, you'll have 8 years. So really to reward those front runners who want to invest in very advanced. So that's one of the ideas. Another one, of course, is that we
ask to wrap up. Sorry, to wrap
yes,
up in a moment.
I was actually.
Go ahead.
I was actually just saying, and another of the ideas, of course, is to give more time for testing of emerging techniques to facilitate that through the permitting. Thanks.
Okay, perfect. Thank you. And thank you for the concrete examples as well. We wanted to launch another Slido poll, a polling question to ask, and this is, I've seen some of the questions coming in from individual members watching, which are indeed about what can the ID do to better promote innovation? And the question here is, do you think the ID needs to promote synergies between reducing emissions of greenhouse gases and other pollutants? And there are 4 options. I see we have votes coming in already. Yes, because basically there is a synergy. So yes, it makes sense. The same kinds of innovations can both reduce greenhouse gases and other pollutants. And then there's 2 no options for different reasons, and a 4th yes option. Yes, but only in certain carbon intensive sectors. what I take from this is there's clearly a lot of interest, or people do see synergies in technological innovations, to the opportunity to kill two birds with one stone effectively. I don't see those numbers changing enormously. I propose, before we go to the rest of the panel, that we launch our third and final Slido question as well, so that we have all our input from the audience, and then we go to the panel and we can use the remainder of the time. Panelists are obviously welcome to comment on these results as well, if you wish. Could we launch our third and final poll immediately on the back of this one? Give it a second, and that question should be a broader question around the main challenges and barriers that you see in terms of this challenge of linking the IED to innovation. And you'll probably need a moment to read through these, but it's touching on a few of the points that Chris already raised just now. And I think you can take two of these again, so you're not forced to go for just the one. But pick two, and let's see the kind of challenges that you with us today see going forward. And I guess this reflects a little bit what we just heard from Chris as well already. We'll give you just a moment, so keep voting, and in the meantime, I'll introduce our other panel members briefly. So we have with us Danny Kroon, who's here from Eurofairs, representing European steel industry, where he's Director of Environment and Research, has been working in the European Association scene for a while, and also specifically on the IED for the better part of nearly 20 years now. And here representing the steel industry, obviously as an energy intensive industry, very much looking to innovate, to reduce its emissions going forward. We have Olga Fraile, Head of Industrial Sustainability at the Spanish Ministry for Ecological Transition. That basically means she's the focal point there for all work relating to the IED and its current review. Has also been with the ministry for more than 10 years now, and previously worked in the private sector as an industrial engineer by training. We have Christian Scheible, Policy Manager for Industrial Production at the European Environmental Bureau, which is the largest network of environmental citizens organizations here in Europe. He originally focused on chemicals, then moved into the IED, and therefore also its BREFs, or Best Available Technology Reference Documents. And he is specialized in looking at how this tool can be used to reach the ultimate goal of zero pollution by 2050. And finally, joining us on the panel, Marco Tapola, also from the Green Foundry Project. He's its coordinator. And for those of you like me who may spot that he has the same surname as Sarah, he's also her father. He's an electrical engineer with more than 30 years experience working on various systems, including air pollution control, energy systems, occupational health and safety, and so forth. And there to provide us with an engineering perspective, again, on developing these technologies, but what can a policy like the IED do to really help build a business case for them? So in the meantime, I see the results have stabilized, and the main challenge that's come out on top is a lack of rewarding instruments for operators who invest in innovation. So that's come out as number one, followed by, yes, Chris already said it, the fact that the IED currently only promotes techniques that are already commercially viable. So let's go then to our panel. And Danny, let's kick off with you. Where's the steel industry at when it comes to breakthrough technologies, and what can the IED do to help move that forward?
Thank you very much, Sonia. Good afternoon, everybody. So for the steel industry, in fact, there are two pathways that are extremely important for the reduction of CO2, namely the so-called smart carbon usage and also the carbon direct avoidance. So the first one is really related to the process integration with the reduced use of carbon and also the storage, and carbon valorization with then carbon capture and usage, and also including with the storage. And the CDA is then really focused on hydrogen and electricity. Now, of course, there is I would say, difference in related to the CO2 abatement potential. when we talk about smart carbon usage, then I would say it is really up to potential of 80% with CCUS or CCS and hydrogen. Whilst when you go for the CDA, the carbon direct avoidance, then we have, let's say, the hydrogen-based steel making and the iron ore electrolysis with up to 95%. It's important to point out, of course, that when we talk about technologies, that, let's say, one size does not fit all. So the, let's say, integrated sites, there are still, I think, 22 in Europe for European steel production. The solutions depend also on the constitution of that site, but also, of course, on the fulfillment of some framework conditions. And I'll come back to that are extremely important. When you look, for instance, to the timeline and also at the TRL level, there is, in fact, the study is going to be launched very soon. Now, there is a European Parliament project on green steel, where also very important RTOs have been participating into at European level. It took 1.5 years, in fact, to do that study. And in fact, we could say that it is expected, let's say, that the breakthrough technologies that we just have been talking about, that they will have reached, let's say, a TRL level of 9 over the period 2030-2035. So it is expected, which means, of course, it can still be questioned. So one another important point is, of course, the framework conditions, because they also need to be fulfilled, in fact, hand in hand with the further technological development of the breakthrough technologies. When I talk about the framework conditions, then it means, amongst others, to have availability of price of, let's say, low CO2 hydrogen production, but also, for instance, availability and volatility of renewable energy, but also, for instance, availability of CO2 and hydrogen transport system. And there, of course, Europe has still a long way to go. Currently, there is only 2,000 kilometers of pipelines that is available. For instance, in comparison with the pipelines for natural gas transport, we have in Europe 260,000 kilometers. So, I mean, there is still some work to do from that perspective as well. And also the strengthening of the high voltage grids. Then, of course, there is also, I would say, and let's say, these framework conditions, they have also been acknowledged, of course, by Wood PLC, as we had just heard from Keir McAndrew, that operators do not have everything in their own hands, so that also the framework conditions to go indeed to industrial deployment needs to be fulfilled. Next to that, there is the economic assessment. And that's, of course, talking about financial issues, which is also extremely important. This study, the European Parliament project on green steel, in fact mentions that when you go to up to TRL 8, which is just one level below, so TRL 9, which could be said that this is above, that it could easily go up to 500 million euro and even more for a technique. When we then, for instance, go to TRL 9, so breaching the TRL 8 with TRL 9 is not so easy, because it's not for nothing called the so-called Valley of Death, because you need much more money then in order to put it up to TRL 9. Then we are talking about between 500 million and 2 billion euro. And then if you really want to industrially deploy it, then it is even much more. Then you go from 500 million up to 4 billion euro. So we are talking here about a lot of money. But we see that the IED, I would say, definitely could support, let's say, the further evolvement of the CO2 abatement technologies. For instance, as also Chris Allen made reference to that, I think already, when you talk about Article IED 15.5, where it would be very interesting to provide there, let's say, some more flexibility in the revision. To test more, let's say, emerging techniques and assess more broadly their possible wider impacts on environment and their compliance, let's say, with the existing BAT conclusions where relevant.
I'm going to have to ask you to come to a close.
Okay.
Sorry.
Maybe just still to point out, in fact, about this innovation, this observatory for industrial emissions. I think this would be an important tool, in fact, to take the issue further. In order to, we support that, just for a more systematic collection of information to identify and promote. And also following, let's say, the cycle has been put now in the BREFs.
I'm sorry, we have to move on. I'm sorry. I know you have more to say, but we have to get around to the other panelists as well. But point noted that you also support the Innovation Observatory.
Yeah. And the CEFI Technical Working Group remains very important. Yeah.
I wanted to move on to Olga from Spain to give us a perspective of what's important for you. Go ahead.
Yeah, thank you, Sonia. Good afternoon to everybody. As a representative from a ministry, perhaps I would like to pay attention what is the role of the administration of this transformation. Are we ready to lead all this transformation? Are we quick enough? Are we fluid enough in order to work in a different way that we are used to be doing? I think this is the first point. Otherwise, these big efforts, as our colleagues has presented, about all this innovation is going to be lost. And for sure, society is waiting for us just to innovate ourselves, the way of we work to each other. Perhaps we have an example here in our ministry that we are forced to work together, energy and environment. And it has been resulted a new ministry, the Ministry for Ecological Transition, that involves both topics. It is a way, just as our Chris Allen has said before, DG Climate and DG Environment are forced to work together. Otherwise, we are not collected and gathered and leader in all this innovation. And for sure, this Innovation Observatory, that was a marvelous project, has to be continued, of course, but not only for this research and innovation in the frame of IAE, but for climate solutions. Greenhouse emissions have to be considered at the same time, because we think that only from an integrated and preventing the point of view, these solutions can arise. As these technologies has been presented, not only from the energy savings, but recycling, because the more we recycle, the more we are saving in energy parameters. So it is basic just to have all these pillars all together in an approach, in an integrated and prevention approach. Thank you.
Thank you. Thank you very much for that. So you're saying one of the messages I took away was greenhouse gas emissions should be considered at the same time as ways of reducing other air pollutants, to take both of those to the next level and ultimately achieve the zero carbon and zero pollution goals. Thank you. Let's move to Christian then from the EEB, European Environmental Bureau.
Thank you very much, Sonia, and good afternoon to everyone. Well, I can maybe just build on what Olga said and fully subscribe to this, that we need to adopt or overcome some bottlenecks and failures, which I think are interconnected in a way, and also the poll answers, the last one in particular, is kind of saying that. First of one is the failure and maybe a misbelief that the market alone will solve it. And this has been pushed very often and long. Now there's a change, luckily, that the EU ETS is the one and only and, well, the cost-effective approach to regulate greenhouse gases, and it should be the only one dealing with this, where we completely disagree, and with other NGOs, that first, because the scope of the ETS is very limited. It doesn't cover, for example, agricultural methane emissions. Okay, it's not an energy-intensive industry, but it's a huge contributor. For the refineries and others, it doesn't account for the embedded carbon depth in the outputs. For example, the products, the fossil fuels they put on the market. It only relates to the blazing or process fuels and not the full picture. So you know, that's the first kind of response we say about that combined approach. What we say, we need the sticks and the carrots. And the stick is the BAT concept, I would say, based on what is feasible. And the carrots is a meaningful carbon price. And I think this is the second point, which is connected to the failures, which is we fail to internalize the external costs. I mean, for the moment, we're getting to a 50 euro, I think, carbon price, which is a record more or less, but it's nowhere near to the real carbon depth price that is the real cost to society. And even DG Move, I mean, they say that the 283 euro per ton is the central estimate, and it would reach 524 euro by 2040. Which is around the corner. I mean, we're talking about energy intensive industries. They need 15 to 20 years return of investment. So this is the price level we are talking about. And we need to kind of fill the gap. And just to complement, and the synergy point is very, very, very obvious here about air pollution. So moving away from combustion technology, because combustion, I mean, where there's a fire, there is smoke. And with this, I mean, air pollution and CO2 pollution in many cases. And here, even there, I mean, the derogation cost benefit assessment, you can choose one method to evaluate air pollution costs. And for the moment, the member states can choose whatever suits them. So, for example, you know, in the EA, you can have this value of statistics life method or the value of life year lost. I spare you the detail. You pick one or the other, you get a factor 3 difference. And the US EPA, they are only allowed to use the one which shows higher air pollution costs. So 6 million euro to be precise. For the moment, we are at 2.2 in Europe. So this needs to be changed. And yes, I very much welcome the zero pollution ambition. And with this, we mean, of course, also to look at other issues like water. And I think the water availability will also be a key driver to the transition, also again, against the combustion technologies. So here also there are a lot of failures to internalize the external costs. And I think it boils down to the, pollute prevention first, and then you pay in full principle. Oh. And we are far away from that. Okay. Then on the BAT concept limitations,
I have to ask you to come to a close as well.
Yes, so it looks backwards. So I think we need to look at the achievable techniques to achieve a certain outcome. And for the moment, we look rather about the economically viable techniques to the operator. And this is a biased assessment. So I think there the innovation observatory, which we hope, of course, would be open to NGOs and should include also the EU Scientific Advisory Board on Climate Change, could have this reality check on whether this innovative technique are really that innovative to deliver on the zero pollution ambition. And I think also there, the EU instruments about, giving money should also look at this. So what is real innovation? The Green Deal objectives, are they fit? Are they met by the modernization funds or not?
Okay, I know it's a lot to cram in, but thank you. I think you managed to cram an awful lot into those 5 minutes. I wanted to come to Marco then, as our final panel member, and bringing us back to the LIFE projects that we kicked off with earlier. As we heard, I don't remember exactly who said it, perhaps it was Marco, we have all these innovations. The question then is there a business case? So for Marco, maybe an idea from your side, how can the BREFs, the IED, how can that help create a business case for some of these new technologies out there? Do you have any suggestions from your side?
Okay, thank you. Good afternoon, everybody. I have short comments dealing with how the innovations can be applied in foundries. I think my perspective is they are foundries now in this presentation. And yes, it is, of course, very positive and also what to come to IED, the stricter limit values are presented in IED. Of course, the more power we have to put on the development of the end-of-pipe technology. The end-of-pipe technology is not the total answer in any case, and this is why we have also focused on the processes itself, that processes have to be more and more clean, more and more green, and the pollution cannot be avoided only with, let's say, extra technology to be cleaned out, but we develop, for instance, in molding process, we develop new binders that are not so emitting at all. And this usually, it takes time. In case, if we have a new innovation technology of cleaning the exhaust gases, it may take some 5 years, yes, but to make a change into the whole foundry process by applying new binding technology, it usually can be estimated to take 20 years. So it is not that easy just to go to the shop and buy new system, because they have to be developed very carefully, and this takes time and money. Okay, Finland is a very good or bad example dealing with the production in foundries. We have dropped in 10 years with some 50% in casting production. Okay, this doesn't come all from the stricter environmental demands that has been put onto the foundries. No, not only that part. This is, of course, one part. You have to use new cleaning technologies. There you need more energy, and of course you need expensive installations. And this is, of course, an expensive way to go forward.
Marco, I'm going to have to ask you to wrap up as well. I'm afraid it's been very ambitious to have so many speakers, and we have to finish on time, I'm told.
Is it 1 minute? Okay. 1 minute, okay.
Yeah.
Okay.
But 1 minute, I wanted to return the floor to Chris, who, as head of unit, to give him a chance in 30 seconds at the end to respond. We have, I've seen lots of questions come in. I've tried to integrate some of those. I think we will have all these questions on record, so we will endeavor to get back to you. And I think there will be opportunities to discuss this in more detail going forward as well. Chris, do you want to wrap us up?
Well, thanks. I'll try to use 30 seconds and not too much more. Looking also at the questions we received, it's difficult to answer to those like that. But I think the fact that we have this list of questions sort of shows that there are a number of challenges we are faced with. The first one is when you're dealing with promoting innovation, and you want to do it through law, you say how prescriptive, how flexible. If it's prescriptive, can it work? If it's flexible, will it work? Will people actually deliver in the end? And those are key questions we are thinking about, and so very valid questions. There's questions about what techniques. Well, the ID is not in the business of choosing a technique, it's in the business of defining performance. And so I think we will keep the ID as being technologically neutral, and that those techniques that work and are viable would be the ones that operators would apply to actually meet those performance. And then there are a few questions on how to establish the Innovation Observatory. Well, we're not establishing it now. For the moment, we're saying, is it a good idea? And I think the first answer we're getting is, it's a good idea, go that way. And then people are now asking, what will it look like? Well, that's for the next episode. I think
I'm
of
told
discussion.
we're gonna have to wrap up, Chris. I know this is.
Can I have 10 more seconds just to acknowledge Marco? You saying something very important. If it's deep transformation of industry, how do we deal with that? It's not a 4-year thing, and that's a central question. And it's really great to have everybody reflecting on that, and we'll continue reflecting with the ID community and wider. Thanks a lot, Sonia, and all colleagues for this discussion.
That's it from us. Thank you very much for a short but sweet, definitely to be continued discussion. Thank you for being with us today.
You're welcome. Bye-bye. Bye-bye.